Hello and welcome to this 6th webinar within the FlexiSoft webinar series. In this webinar we're looking at diagnostics within the FlexiSoft system. My name is Ian Keatley-Smith. I'm one of 3 functional safety engineers at SICK UK. The other 2 are Seb Strutt and Martin Kidman. So the agenda for this webinar is to look at the diagnostic information, and first of all we're going to have a look at what networks are available. So which networks can we connect to with the FlexiSoft to send all the diagnostic data back. We'll then have a look at the data that's available to you. We will then look at how you configure a diagnostic card within FlexiSoft Designer software. And we're also going to look at how you configure a Rockwell PLC. So to get the diagnostics back to the PLC, we obviously need to send data from the FlexiSoft up, and we also need to see how that data is interpreted in the PLC that we're connecting to. So we'll do that in section 3. Then number 4, where to get more information. And finally we'll look at the future webinars that will be coming within the series, and also details of the ones that have gone previously. All these webinars will be recorded and available for download from the SICK website. So looking at networks available, here we have an image of a FlexiSoft CPU. In this case it's a CPU 0, and up at the top there you can see, as I'm highlighting with the cursor, the memory plug. So this memory plug here holds all of the configuration data, and the power from the memory plug, this simply pulls out, and when you push it back in, then the power that's on here on A1, A2 powers up the internal electronics within the CPU, and it also powers up the back plane which connects all of the devices together. So the first gateway that is available to us is EtherCAT. So you can see that it has 2 ports, EtherCAT in, EtherCAT out, and a number of diagnostic LEDs there to tell you the status of whether the configuration or the program is running and if there's any errors. The next gateway that's available to you is Profinet IO. Again, it's Ethernet based, so you can see you've got the 2 ports, top and bottom. We also have the ability to connect it to Ethernet IP, and again 2 ports, top and bottom. And the next one is Profibus. So if you're looking to connect to an older Siemens system with Profibus rather than Profinet, we've got that option available to you. The next one is CANopen. Then we have Modbus TCP, CC-Link for connection to Mitsubishi PLCs. And we also have DeviceNet, so if you want to connect to a legacy Rockwell system, then we have DeviceNet available as well. So all of the gateways within the FlexiSoft Designer are bi-directional, so we can send data from the FlexiSoft down to the PLC, and we can also bring data back up. So data down, you'll see in the next slides what information we send down. But information coming back could be something like a reset signal or some sort of handshaking to say the PLC is running. So if the PLC isn't running, the safety won't run in, and things like that. You'll notice as well that the colour of the slices here, so the FlexiSoft CPU is yellow and the diagnostic cards are all grey. So how it works in SICK is that if it's a yellow card, it supports safety. If it's a grey card, it's only for diagnostics and non-safe communications. So as you can see, the 2 arrows there, backwards and forwards, are grey, and that's just representing the fact that it is non-safe communication that's being transferred backwards and forwards between the PLC. If you do require safe communication between the FlexiSoft and a safety PLC, then we do offer a gateway which allows that to occur. But please get in touch with us if that is part of your requirement. We can also have up to 2 diagnostic cards per system. So now we can see in the image we've introduced a CC-Link card. So now we have a DeviceNet card and a CC-Link. So we can communicate on 2 different networks to 2 separate PLCs. There is a presentation or webinar that started the series called an Introduction to FlexiSoft, where we discussed the hardware that's available to you. And on that presentation it was stated that you can have up to 12 cards attached onto the side of a CPU. I just want to make a point here that the diagnostic cards do not count as part of those 12 cards. So even though we've got 2 diagnostic cards here, we could still have 12 safety cards attached onto the side of that. So that is the capability that we have. Also, there are 4 CPUs within the FlexiSoft range. We're showing here a CPU 0. We also have a CPU 1, a CPU 2 and a CPU 3, and all of the gateways are supported by those different CPUs. So looking at the data that's available, there's just an image there just to say we're going to be looking at Ethernet. So when you go into the software, and you'll see this when we go into FlexiSoft Designer and we start putting a program together, you have that symbol which shows FlexiSoft to Ethernet IP. So this is the data that's going from the gateway to your network. And over here we have what's called logic results. So this is results from within your logic engine that you can send directly over to the PLC, and we automatically populate it here for module 1, 2, 3 all the way up to 12. So we will automatically send the status of the inputs over the gateway to the standard PLC. So you're going to get the status of everything that's connected to the FlexiSoft controller. And as well as having the input information coming back from the 12 cards, we also automatically send you the output status. So if you were to have, as it's shown here, an XTIO card which has got 8 digital inputs and 4 digital outputs, we can send you the status of the outputs and the inputs. And then down here, just slowly going off the screen, is we have access to a lot more data that we can send as well. So that is the data from the FlexiSoft to the network. The other symbol that we have is, you can see this has changed now, so this is from the network to the FlexiSoft. So this is the information from the PLC coming in, and we have an array of, a whole selection of data that we can send. In reality, probably output data set 1 would be enough for you. There's more than enough data there, and you don't tend to bring much data from the PLC into the FlexiSoft. Customers are more interested in knowing what's going on with the FlexiSoft system to diagnose faults and increase production, so mainly it's the other way. So that's the data that's available to you. So now let's go in and have a look at designing a configuration within FlexiSoft Designer. So we've opened up the software, which is a free download from our website. Simply go to sic.com and type in FlexiSoft Designer and you'll find a link. So we're going to add in CPU 0 here, and that comes into the configuration area, as you can see, and then you've got your various gateways available to you. So what we're going to do is select what's called a gent card, which is for Ethernet. I'll now select an XTIO, which gives us 8 digital inputs and 4 outputs, and we'll start to attach some devices on here now. I'm going to add a dual channel e-stop on here, but rather than bringing it in as a dual channel e-stop, I'm going to bring it in as 2 individual ones. And now what we're doing is switching on test pulses. So if you look at that X1, X2 terminal at the top, that is now sending out a pulse, and we'll cover that later within the reports. I'm now going to add a safety switch, and again I'm going to bring that in as 2 separate inputs as the hardware, and now we're going to select a reset push button. Just double click on it, you can see it's populated in input 5, and we'll have external device monitoring on input 6, because we're going to be switching some contactors and we need to monitor those contactors back in. So now I'm going to select a motor, put that on to Q1, and then we'll put a lamp on to Q2. So I go into the gateway here, and over at the left hand side there is your gateway to the network, and there's my XTIO, and you can see the status of those inputs are automatically being sent to the PLC, and my lamp and my motor are automatically being sent to the PLC as well. So now I'm just going to drop into the logic editor. I'll just make this bigger so that we can see it. I bring the two e-stop channels over and bring them into the editor here. There we go. And I'm now going to select the two switches. You can see that when the device has been used in the logic it goes green, when it's not been used it's black. I'm going to go to function blocks here and go for other, because we've got emergency stop block here. So I simply join the dots up for the emergency stop, double click on it, and you can see here that you can change it from dual channel equivalent, single channel, or dual channel complementary. So complementary would be normally closed. We've got two normally closed, and then I can set a discrepancy time, so it has to see both of these channels break within 300 milliseconds of each other. I have one output, but I'm also going to select this one, use fault present. So if there's a discrepancy error, then I'm going to get a fault output from there. Now I'm going to bring in the similar block here for safety gate monitoring, and I'll attach my two inputs to that. And just before I go over there, double click on the block. You can see here at inputs, you can have it as single, dual channel, one pair, complementary, one pair, or you can have two pairs of switches coming in. So we are going for dual channel equivalent, and you can put a function test on there, which means during power up it has to see the gate open and close. Choose fault present, and there's my block there. Now I'm just going to do a right hand click here and make a new jump address. This is just to keep the program tidy, and we'll just say e-stop is OK. So if the e-stop's OK, then the enable will be high, and I'm going to make another new jump address here, and this is going to be my gate is OK, and say OK to that, and attach that to the enable on there. Now over here on outputs, what I want to do, if I get a fault, I want to send that information over the Ethernet to the PLC. So in the HMI, for example, I could say that there's a discrepancy fault. So I'll just rename this as e-stop discrepancy fault and say OK to that. So if those two channels, those two input channels exceed, when you break them, they break longer than 300 milliseconds, that fault present will go high. So similarly, here's the gate, so gate discrepancy fault. Let's say OK to that. And now what I'm going to do is just select this logic and just move it up a little bit out the way, because we're now going to bring in a reset block. We want a manual reset if the safety gate is opened or the e-stop is pressed. So here's my reset block. Simply double click on it, go to I/O settings, change it to 3 inputs, say OK, and then I'm going to select the jump address e-stop OK, connect that to release 1, then select gate OK and select that to release 2, then go to my inputs and select my reset to my reset input here, and then I'm going to go to outputs. Oh no, not yet actually. I'm going to go to EDM. So this EDM block here is going to check that the contactors are working okay. So there's my control input. There we go. And go to my outputs and look at the outputs of my XTI. There's my motor. So my motor will be driven from output 1. And my lamp will be going from reset required. And if I go back to my inputs, I then have external device monitoring. So when the motor is off, EDM has to be high, and when the motor is on, EDM has to be low. So I'm just going to create, you can see there's an EDM error bit there, so I'm going to take that, because now I want to send that over the Ethernet as well, Ethernet communications. So if I get a fault in my contactor, I want to tell the operator that's where the problem is. And now we can run the simulator. Now if I put this straight into run, wait till you see what happens. Immediately the EDM block goes into error because the motor is off and the EDM input is off. So therefore we're getting an EDM error. So what we need to do is just pop back out the simulator, pop back in again. and I need to select EDM as high. I'll just select that these are all okay as well and put it into run. Now everything's working fine, so the lamp is flashing saying reset required. Your restop and gate are okay, and you can see them being mirrored into the reset block. So I'm just going to step it 200 milliseconds, release the reset, and you can see the motor is on. Now that needs to go off, and now everything will work absolutely fine. So if I hit the e-stop push button, then the motor will go off, and then the EDM has to come on. So what you sometimes find with the simulator is that, as you saw earlier on there, when I had an EDM fault, I had to stop the simulator and start it again. So yeah, sometimes I take these faults out. So this is just showing you where those bits are. So there's your discrepancy fault, showing you where it is. And now what we're going to do is, I would like to send a reset from the PLC into the FlexiSoft. So we want to reset from the HMI. So we've put that there. If I come down to here and delete this here, and then if I go to my inputs from the module, you can see down here, there's my reset from HMI. So now we're bringing the reset in, and you can see that it is grey now rather than yellow. So it's showing you which tags are safety and which tags are non-safety. So anything that's yellow is a safety signal, anything that's grey is a standard signal. So it just allows you to visualize in the software where these signals are coming from and the integrity of those signals. There is another thing which we haven't shown here, and that is this symbol here. So this one here allows you to add notes into your logic. So what I always recommend is that you drag this over and you write notes of how all this logic works, and that information is sent down to the memory plug. So when you come back and look at the FlexiSoft at a later date, at least you can get an understanding of what this logic does and what the thinking was in designing it this way. The other thing you can do is up here, you can see it says page 1. We can change the names of the pages by clicking on this icon here with the pencil, and we can also add additional pages by clicking on here. So when you write your safety code, you should write it in such a way that it's easy to understand, and you break it down into small sections which are individually tested. So that's just a recommendation. And if you want to find out more about how code should be written and how it should be tested, then please refer to the safety standards, ISO 13849 and IEC 62061, which are the two safety standards when designing circuits for machines. So to set up the communication card, it's very simple. All you need to do is go up to interfaces and select the gateway, and down here you can see we've looked at this section and this section already, which is sending information to and from PLC. Now we set up the configuration. So this is the device name and its IP address. This is the FlexiSoft gateway, and then we show this arrow. This is the information coming out of the gateway to the PLC, and this is the information that we send here. So you can either have the PLC requesting it, or what we can do is we can do it as a change of state or a heartbeat, so it automatically updates. So the gateway can work as a master or a slave, and then you select which data sets you want and your heartbeat interval. Down below there you'll see this is information from the PLC back into the FlexiSoft, and there again you can either set it up the PLC writes or the gateway reads from the tag file at a specific heartbeat rate. In this case it's set to 5 seconds, so every 5 seconds it would read the 5 data sets. This is the IP address of your PLC, of where you're connected, and then we have the ability to have up to 4 additional sockets if you want to connect, get data to other sources as well. We have those options available to you. So that is how to set up the diagnostic card within the FlexiSoft Designer software, and just showing you how to write a bit of logic and get the data bits backwards and forwards, and how to set a reset from an HMI. So it's relatively simple, it's not too difficult. So the next thing we'll do is we'll look at how you actually do this in the Rockwell PLC. So again, there is the CPU, there's your bidirectional communication to a Rockwell ControlLogix PLC. Now first thing you can do is download the EDS file. So if you go to the SICK website, type in the card that you're using, so in this case we're using a Gent card, and you can see it takes you straight to the area where you can download the EDS file. And that EDS file will then be used in the Rockwell PLC. So that is relatively simple to do. Then when you start looking at the Rockwell software, you open up Studio 5000. Now what we've done here is I've actually pre-installed the EDS file. So I go to Ethernet New Module, and how you install EDS is you go up to Tools at the top there, and there's one called an EDS Installation Wizard. So this opens up, and what we're going to do is just deselect this, and when you've installed the SICK parts you come over here and you can click on SICK AG, and it shows you the devices that are already installed into the Studio 5000 software. So you can see there as well we've got what's called an FE Pro Gateway, that's your FX3 GEPR, and that's for safe communications, that's your safe diagnostic card. And then we've also got a Microscan 3 Ethernet IP laser scanner there, which can attach directly into the controller. Now both of these additional cards would be using a Guardlogix processor from Rockwell. So here we've got the new module, and we just type in a name, so we'll just call it a Gent. We give it an IP address, so I'll just give this an IP address of 2. And then we have to go into module definition here to tell it what data we want to send backwards and forwards. So you go to change. From the drop down here you can either have bidirectional or just input data. It automatically populates the number of bits and bytes and things like that you need. You then say OK, and what it will do then is it will then add over underneath Ethernet, you can see it says Flexi Gent and it's got a picture. If you go to the controller tags, then once that opens up, you then have your Gent, and there is your input and output data. So if I just select that there, this is the area where you can get the data from the inputs from the FlexiSoft, and there's the output data. So the input data would be showing you the status of all of the I/O, as well as information from your network. And the other one there is the output data, so that's for example, the reset push button that we were sending from the PLC over. And once you've done that, then fingers crossed, you'll start to get communications between your FlexiSoft and your Rockwell ControlLogix PLC. So if you are having any issues or difficulties with that, then likewise, I always say get in touch with us, and we'll be able to help you out either via a WebEx or telephone support, but it is relatively simple to set up. So where to get more information on all of this? Well, there's the SICK website to start off with, so all you have to do is go, I am looking for, type in there Flexi, and then over here you'll see there's the FlexiSoft controllers, just click on that, and that will take you to the landing page. Select Gateway, and then it will list all of the gateways that are available to you. And then if you want to get more data on those gateways, you simply click on the blue descriptor, and then it will give you access to download the software. For example, with the Gent module we had the EDS file. If it was Siemens you would have a GSD file, and there's all the literature there in it as well. So literature wise, from a manual point of view, we have a hardware manual which goes in and describes all of the hardware, and we also have a dedicated manual which describes how it's all configured in the software. So between those two manuals, everything that you need is there, so it's got data on all the assemblies and everything else. The other place which is very good to look at if you're interested is the YouTube channel. So simply go to SICK Sensor Intelligence, click on the search and type in FlexiSoft, and from there it will take you to an area where you can download loads and loads of videos. There's this section here which is a combined 10 video set which goes through everything that you need to know. I also recommend that you subscribe. If you've got a Google account, you can subscribe to this channel, and you can also hit a bell icon which gives you notifications, so every single time there's a new video that comes out, you'll get a notification. And it's not just about the products, it's about the application of the products, and there's lots of useful, helpful videos in there for the entire product range within the SICK portfolio. For webinars, the ones that have already gone are the webinar 1 was an introduction to FlexiSoft, which went through all of the hardware and what's available to you and showed you a basic program. Webinar 2 looked at the function blocks, and we looked at the most popular function blocks. There's many function blocks within FlexiSoft, but we just chose the main ones there, so if you're interested in that, you can go and download that on demand. The third one was looking at FlexiLoop, which is like a remote I/O system with the FlexiSoft. And with the FlexiLoop, this is where diagnostics become really useful. So if you are using Loop, then you tend to use that with diagnostics as well. Webinar 4 looked at the connection of FlexiSofts. So if you've got multiple CPUs and you want to connect them together, up to 4 CPUs can be configured using what's called FlexiLink. For webinar 5, we looked at what's called FlexiLine, and again that is connecting multiple FlexiSoft CPUs together, but with FlexiLine we can connect up to 32 CPUs together. We've just concluded webinar 6, which was a brief introduction there to diagnostics, and the next webinar in the series, and the final one within the series that will be coming out, is looking at an example machine of a robot palletizer. So we'll have a look at a machine. We will then look at the safety on that machine and start to build up a FlexiSoft program for that application. And that will be the end of the webinar series. If there's anything in particular that you have interest in or would like to know more information on, by all means get in touch with us direct. And what we'll do is we could maybe do a one-to-one session, or we could add on another webinar within the series to cover specific elements if that's of interest to everyone. So thanks very much for your attention. As I say, my name is Ian Keatley-Smith. My details there are at the bottom left, so there's my email address and my direct mobile telephone number. I've also put on Martin Kidman's details there as well. So I'm based down in Worcester, just the south of Birmingham in the UK, and Martin is based up in Liverpool. So between us we cover the whole country, but Martin tends to concentrate on the north and I concentrate on the south. And between the two of us we also look after Ireland. So please get in touch with us if you have any questions. But thank you very much for your attention. I do hope you found the webinar useful, and I wish you a good day. Take care. Bye now.